Guohan and me will deliver this session about the Dash. So this page, SONiC has been introduced a lot. I will skip most of the information. But one thing I want to highlight is SONiC has been largely deployed in the data center, in the enterprise, retailer stores, in the campus, and also, much more. So SONiC on this page is mainly on the switch, but today's topic is about, go beyond the switch to other intelligent device, okay? As Xin mentioned, SONiC community joined the Linux Foundation in this April. We are far more closer to the software community. So what is Dash? Dash is the SONiC-based open source project in order to achieve 100 times the performance and the scalability growth and improvement. But how? So by offloading a lot of the services to the specific hardware. So at the nutshell, Dash has 3 key aspects. The first one is the standardization. As Liat presented, there is a controller, and we are trying to standardize the API face to that controller. So the second part is about the offloading. We are trying to offloading the data processing workload from the CPU. So that's the second part. The third part is about the acceleration. Again, it's about how we accelerate the data processing to support the new scenarios, AI, autonomous driving. So we need to move the compute far more close to the data instead of move large data to the compute side. I think that's the 3 key areas for the Dash. So for the Dash, we have the very abundant hardware, intelligent hardware devices like the smart switch, Intel and Media introduced. We also have the DPU or XPU, whatever you call it. So we have cloud providers, in this community. We also have the Dash, the P4-based behavior models. If you do not have a hardware today, that's fine. You can use the P4 model to try it. That's totally okay. So we also have the standard API test suite. We also is SONiC-based. You can leverage the current SONiC community investment scenarios. A lot of the things can be reused for the Dash project. Okay, so with that, I will hand over this to Guohan to go deep on the technical side.
Yeah. Today, I think I mainly talk about one use case in Azure, and to use a Dash. I hope I can convince you that the Dash is real and it's really needed in Azure, and we're really working hard on it and making progress on it. So, so the use case for us is this Dash for SDN appliance. Let me explain. Right now, our SDN is on the host. So basically, when the VM sends a packet, this blue dot, the packet, the NIC will do those magic to encapsulate the packet, do the packet transformations, and then send to the physical network. And the physical network just deliver the packet to the other VM's host. And on that VM, the NIC on the other VM that do the decapsulation, do the other magic, and then decapsulate the packet and send the packet to the VM. So all the intelligence here is on those NICs. So what we're trying to bring is to bring this SDN in the appliance concept, to this cloud. So in this case, we have a new VM, this green VM. For this green VM, it has a NIC that have less functionalities. So what it does is that then in the cloud, we have this SDN appliance, which is running SONiC and do all those magics that previous NIC does. So what happens that in this case, if the VM still want to talk to the other VM on the right side, the NIC will just blindly knows the SDN appliance IP address and then do the simple encapsulation. In that NIC, there's no any stateful transformation for that VM packet. It will just do a stateless encapsulation and send this packet to the appliance. And in this case, appliance is doing all the smartness, do the connection tracking. I'll describe it later. So then the SDN appliance will strip out the this yellow packet header, and then do all those magic, and then re-encapsulate and put the original the blue headers in this packet, and then send to the VM. In this case, the VM on the right side does the same thing. So the benefit here is that once we do this, so we think the cloud is like the magic of the cloud is that you have a resource pool, you have a lot of resource that you can use. So in this case, we decoupled the SDN function with a particular NIC. We move those functions into the appliances. The appliance can be a pool of IP, a pool of DPUs and those smart devices. Then if the VM has a need to do a lot of connection, do a lot of these packet transformations, then you can have more appliances aligned here and help to increase the performance. So this is one of the reasons that we put those SDN appliances in a pool, and then you can use it. If the VM doesn't use much, then we can save the resource for the VMs that needs those computing powers. So that's the reason why we are having this new model, so to address some of our needs, in terms of performance, in terms of multiplexing in this appliance use case. So then this is we're called the general packet flow, how the dash processes this packet. So there's two directions related to the VM. One is outbound, meaning that VM wants to send the packet out. It will send to the appliance first, and the appliance do the processing. So in this case, the VM sends the packet. We do a VNI lookup because it's VXLAN, and then do a ENI lookup to figure out which VM this packet belongs to. And then rest, then we do the connection tracking, SL routing, all those SDN functionality, and then send the packet to the network. So on the inbound, when the packet comes, right? So we because of the VNI lookup, we know this direction, whether this is outbound or inbound. And if it's inbound, then we'll also do the ENI lookup to figure out which VM this packets are destined to. And then the rest will do connection tracking, routing, SL, and then and finally, as a last step, once we process the packet, then we need to do another layer of VXLAN encapsulation because the SDN appliance is not on the VM. It's not near the VM, so it's going through the network. So we do the VXLAN encap and send to the VM. So this is a very detailed example we work out. We define this this pipeline in the P4 language. And so anyone can, if they want their own pipeline, they can also use the P4 to describe their language. So basically, let me see. So from the start, we'll do the route lookup and figure out the routing table. The action would say this is a VNet, and then it goes to another routing type, look up the VM, and the VNet action. In this action is doing the mapping table. Basically, for this particular VM, we know the IP. We need to find the host. And then we find the host, and then get the host IP, which is 101.1.123, right? So then we do the encapsulation and send it out. So this is a very detailed example of how we make it work. So then, once we, the community, we have figured out how the pipeline looks like. Then, we design the SONiC stack. It's basically customize the SONiC stack to fit this needs. So the left is all the containers that we have in the SONiC, but in this use case, not all the container needed. So we cross out those containers that's not needed for this use case. And the main flow is that we have this GMI container which is receiving all those configuration from the GMI, and then it sends those configuration to the Redis database. Then we have this we have this developed a new awk agent. We call this a dash awk agent, which processing all those dash flow logics. So the dash the SWSS read back those configurations and then translate into the SI, and then we go back to, we send those side comments back to the Redis server, and then, we have defined this side-APIs. Then, all the, DPU vendors support that side APIs, and we'll configure the DPUs. This is, like a more detailed flow, define where the, the API is, what is the model for the GMI. We use Yang models. I'll quickly go over this. So, here is the examples of the, our configuration schema. We have an initial implementation already working, and integrating with DPU vendors as it's in progress. So, yeah. So it's a very active communities. We have weekly meetings on those topics, and you are welcome to join and help and to build the community. It's a very exciting areas. Thanks.
Okay, that's all. Yeah, thank you, Guohan. And so let's take 5 minutes for Q&A, and please address that who the question is to. Right? We have 3 talks here.
I think that one key factor for this solution is actually the controller. Without the controller, it's kind of like meaningless. So what are the plans? I mean, do we want to open such a project for SONiC to build such an open source controller or reference controller, or what are the thoughts around that?
I guess this is a question to Microsoft. Yeah. I think for this Dash community, I think we're focusing on developing the APIs, standardizing APIs, so that and focus on developing the box that supports this. Once those the API defined, I think for different use cases, they may have different controllers to configure it for different yeah. So that's a focus that we're focusing on. So we're currently not focused on on the controller side.
Yeah, can the Dash replace the SI, or it's complementary?
It is complementary.
Okay.
Because this SDM function is a new set of functions, mostly related to the overlay handling and the connection tracking. All those are not existing in the switch world, switch ASIC world.
Okay, thank you.
And it's basically for Guohan. You said it's available on the behavioral model, and so there is a SAI for behavioral model, and there is a SYNCD already available. So it's on the Dash where the SYNCD can be found.
Can you repeat the question? I didn't quite.
You were saying that there is a behavioral model, and there is a BMB2. I believe there is a SAI for it. Is there a SYNCD available already for the?
Is there what?
SYNCD.
Oh, SYNCD available.
It is a working process. Let's say, like each vendor is responsible. Sorry, each vendor is responsible to provide the SYNCD for the DPU that will work for that, and this is a work with progress. Each vendor is working on that, and the behavioral model is defined on the SAI Dash branch. It will be merged to the SAI in general, but it is available already. And every time that there is a definition that is done, then there is the behavioral model of the P4, and it is available on the Dash GitHub.
So it won't be like a SONiC to have the SYNCD as the part of the SONiC. For the smart switch, it is expected that the vendor of the DPU should provide the SYNCD with their SAI.
No, it is just a start. So
okay, so
eventually, I think that the idea is that you will be able to run SONiC on DPU with the with what all is needed to have it like functional, like you're doing with a switch itself. But since it's just a bring up or a kick up of that project, so each vendor is now working independently until it will be available.
Okay.
Hey, Guohan, quick question on that use case slide where you talked about the scalability with the appliance. It's also possible to scale with those servers in the host level with a SmartNIC and applications or processing being done in a SmartNIC. So what's sort of the next level motivation of the appliance?
Oh, I think many, my understanding of the cloud is really, they're treating this resource as a pool, to compute the storage and network, right? So in this case, you can think of the SDN function processing is a resource pool. You have those, all those devices that be able to do those SDN, complex SDN processing, right? So now, previously, all those processing is, hard-coded in a server, right? So on a particular server, and, because of the customer requirements, some customer requires, more processing, some customer requires less processing, right? So then you end up, either under-provisioning or your server fleet to handle the 99% of the needs, or over provision, handle your 99.59 needs, right? So then there's a trade-off, how you provision your server, because those hardware is hard-coded on the host, right? So in this appliance model, what we do is that we move those resources into the cloud. Think about, right? So somewhere, in the cloud, as a resource pool. So then any VM, right? So they want to use it, depending on their usage. You can sign, one appliance or two appliances, or if multiple VMs doesn't really use that much, then you can aggregate all those VMs and then simply put one appliance to handle them, right? So in this case, you are gaining this multiplexing effect. That's a power of the cloud, right? So originally, the cloud is be able to leverage that effect and provide the commodity to the whole world. So we're applying exactly the same idea to this SDN processing, because the SDN processing requires a lot of resources to do it.
I have one question about the connection tracking part. I think it's for Intel IPU. I'm actually very interested in that part. Is there any existing devices already integrate the IPU inside of it, so we can actually try the connection tracking on the switch? This is mostly for Intel.
Oh, okay.
The connection tracking is an integral part of the IPU that we have implemented, and we offer multiple million connections per second with that. Currently, it is available as the IPU itself will PRQ next year and is not integrated into any product at the moment. The part we are working on is with the smart switch right now that we want to build using the IPU. And also it is available as a standalone NIC in a server as well, once it PRQs next year.
I see. Also, I'm looking at the behavior model. Is there any update on the P4 BMV2, so we could actually try it on software instead of before the hardware become available?
Yeah. So as Rashma described in her slides, current use case is VNet-to-VNet connectivity, and that's what you see on this Guohan slide. So the packet transformation support is already there. The current plan is to add more functionality that is kind of new to the simulator itself to support connection tracking and stateful operations. But you can try basic scenarios like what is described in here, VNet routing, encapsulation of the packets to deliver it to the final destination, etc. So all this is available.
Excuse me, this is Saad from Dell. Just a very, I should say, maybe a silly question. All the behavioral model you explained is based out on P4, right? I just want to understand the current maturity level of this, because in the field, the way we have tested, we still find some gaps in terms of P4, right, in production, in terms of flow and this. So, I mean, have you done some sort of testing, benchmark, like different scenarios, some more details on this? And if that is not done, is there any alternate available except P4 for the flow or other control part?
Yeah, so first let me emphasize on the scope. So the scope of the behavioral model is to ensure correctness. So we are not doing any kind of performance benchmarking, anything like that. Only correctness of the processing. Now, having said that, what is available is packet transformations that are native to P4. And stateful operations, this is kind of new to the P4 community itself. It's discussed in parallel in the P4 working groups like PNA, etc. And we're trying to work with them as well to either bring those into BMV2 or maybe try and do it on our own and see if we can at some point converge in that. So the gaps right now is basically around the stateful operations like learning and the connection tracking. And second one is Dash has some kind of fancy match types like lists of ranges, lists of prefixes in one rule. So this is also a work in progress.
So I just want to add one more comment on this P4, right? So really the Dash project, the P4 here is just used to define the pipeline to ensure every vendors understand what exactly the behavior they need to deliver, right? But really for the Dash project, based on the P4, we generate the side APIs, right? So each vendors, they just, they need to implement the, whatever mechanism they use to implement the side APIs as long as those behavior is correct, right? So then the Dash project, is working and we're, based on the, we're not say, absolutely depending on that behavior model of the P4, right? So it's more about a reference model where just use a more precise language to describe what is the behavior we need.
So, so it's kind of like advanced documentation tool, basically.
So I guess a quick question for Guohan. In this particular example that you talked about, moving SDN in host to SDN in appliance, so once you move SDN in appliance, the host functionality essentially, becomes just encapsulation and decapsulation, and then not much of the smartness is basically there. So now the configuration that remains on the host is to say that, okay, which VNI to encapsulate with, and what's the underlay IP that you need to basically use in order to talk to the appliance. So in that case, my question is that will controller ever be talking to the host, or is it just a hard-coded configuration on the host once the SDN moves to the appliance?
I think because now we have additional resource, right? So the controller have the lot of flexibilities in terms of moving those smartness around, right? So it has a choice, depending on the load, depending on the, whether they estimate the host can do it, or where do we put the resource to save the the money, right? So then the controller has the flexibility. It can configure the host to do this offloading, or in case the host can do it, then it can still offload to the host.
No,
okay.
The question I have is that once you move SDN into the appliance,
yeah,
VM no longer has the smart NIC. VM has just a skinny NIC that we basically talk about, right? Now, essentially, at that particular moment, the configuration that goes onto the skinny NIC is essentially through the controller talking to it, or is it just it's just a hard-coded configuration onto the.
Go ahead. Do you mind I take this one?
Yeah.
So I think this is really not about the smartness needs to move away from a place to another place, right? This is more about the network has not been having this smartness, right? Now it's possible to have this smartness as well, right? So that allows you to do a little bit more flexibility for the resource pooling. Where do you want to put the resource to get the CPS, right? It's not about A or B. It's about A plus B. Right, so I think I hope that clarifies the goal. Right, it's not about Right.
But that way, you are not achieving any, I guess, the cost reduction, so to speak, because if you move all the resource pooling, all the CPS that you want to do it in the cloud, the idea is to essentially have only the performance NIC or the skinny NIC in the VM, no?
So if you think about the peak load, right, the peak load is where you need to provision for. right? But the 90 percentile or the whatever lower percentile is where things are the broader fleet, right? So if you have to provision everything to the peak load, that's where the cost is, right? But it doesn't mean that the NIC needs to become dumb and can only do a single fixed function. The NIC probably can do the same set of rich function, but with a little bit less peak load capability, right? So, and then if you can inject the same level of smartness in the network, then you have a big resource pooling over there, which is more cost efficient. Right.
So, question regarding the traffic from the VM to the SDN appliance. So, given that that is not doesn't have all the, it's basically an encapsulated traffic.
Yes.
So, is the traffic management done mainly on the other side of the picture, on the right side, after the SDN appliance to the NIC?
When you say traffic management, you mean all those smartness?
Yes.
You know, it's in the SDN appliance, right? So SDN, you know, I think about the sorry, the appliance is extension, you know, to the existing NIC functionality, right? So they just move all those, I mean, have all those functionalities in the appliance.
Thank you.